All right, section 4.2 is a logical follow-up to section 4.1. 4.1 and 4.2 both talk about finding the side lengths and angles of triangles when we don't have right triangles, right? Right triangles, we use Pythagorean theorem, they're really straightforward, but not all triangles, as you know, are right triangles. Law of sines is tricky because there are these ambiguous cases. So if you did your homework, you know what I'm talking about, and it makes it challenging. We don't have that with law of cosines. Okay, so law of cosines is a little bit more straightforward in terms of how to find it. Now, I will say, once you find certain pieces within the law of cosines, you might find yourself asking, well, do I have to use the law of cosines to find the rest? And the answer is no. You can still go back to the law of sines and use that within what we're doing. Okay, so there might be places where you're looking at this and saying, I think it'd be easier if I just did, and that's okay. There's nothing wrong with doing that. So we're going to take a look at the law of cosines as we get started. So we've got angles A, B, and C, and we've got sides A, B, and C, and as always, side A is opposite angle A, and so forth. Okay? So there are three formulas that are all the same. Okay, so if you're looking at this and you're like, oh my goodness, she just gave me three formulas. No, I didn't. These are all the same formula, right? Angles A, B, and C, sides A, B, and C. And what you can see happening in terms of formula structure is that if this is A on over here, then the angle A is over here. So the angle and the left-hand side match. And they do that in all three formulas, right? And then the other pieces are just the other sides. So if I don't have sides B and C, then I've got B squared and C squared over here. And you see the B and C inside of here. And the same form happens for all formulas that are written here. Something else that's worth pointing out here is that if you did not have this piece here at the end, what would you have? A squared equals B squared plus C squared. What is that? That's the Pythagorean theorem. And that is exactly what would happen if this angle A here at the end were 90 degrees. Okay? So this is really a generalized Pythagorean theorem. That's what it is. Okay? And so we have our three formulas that are really just one formula. And I even can say they're one formula because you can just relabel the sides, right? Like they tell you this was A, B, and C. You could just switch them all around. It doesn't matter what we label them as. We just label them so that we can communicate effectively with one another. That's why they're labeled. And then this is sort of a description of what you're seeing happen here in a general term if you're more of a vocabulary words person instead of a formula person. So it's written out as a description. All right, you ready to try one? Of course, you bet. All right, so here's our first one. So we're going to solve the triangle. As you know, solving triangles means finding all the sides and all the angles, and they always give you three to start with. If you're dealing with something that's a right triangle, you only need two because you've got a right angle as well, sort of embedded in there. But for all the ones we're doing, we're going to be given three sides and angles and a combination of those things. Now, here's the interesting thing about the law of cosines. In the law of cosines, we can be given an angle and two sides, or we can be given three sides. And we can actually find it. The law of sines doesn't work that way. With the law of sines, you had to have an angle given. So if you have three sides given, the law of cosines is the only way to actually make that work. So far, so good? Okay, so let's do this example one first. So angle A is 67 degrees. And then we have sides B and C, which are 8.9 and 7.2. So if we want to think in terms of which of these three formulas does it really, really match, it would be the first one because, we've got angle A given to us. So if you want to sort of be really specific on grabbing which formula, it will be the first formula. So this first formula says that A squared equals B squared plus C squared. That's the Pythagorean theorem part. And then we subtract off 2 times the same sides that are on that side of the equation, B and C. And then the cosine of the angle that's on the left-hand side, which is angle A. That's the structure of this formula. So what we're going to end up finding as we do this is we're going to find side A. So side B is 8.9, so I've got 8.9 squared. Side C is 7.2, so I have 7.2 squared minus 2. Side B was 8.9, side C is 7.2. And I have the cosine of the angle that was given, which is 67 degrees.
The calculator have to be in agreement.
It will have to be in degree mode since we're working with 67 degrees here. Yes, that's a very good point, and I'm glad you made that, Isaiah. Do make sure that as you're working through these sections, the same thing was true, I think, exclusively in section 4.1, is that we were only working in degrees as well. I don't think that we had any problems that were given to us in terms of radians in those. Okay, so grab your calculator. Let's find some side lengths and angles and so forth and add them up. I'm going to write some steps along the way just so that you can see them. But if you wanted to do the right-hand side, all of it from start to finish in your calculator, you could do that. All right? Like you can type in 8.9 squared plus 7.2 squared minus, you could type it all in from get-go. I'm going to write some details in just so that I have some of them written in case you're looking at it later and you're like, where did that come from? So this one's 79.21. I have 51.84. And then I will go ahead and put all of this into the calculator at once, making sure I'm in degrees, which I'm not, so now I will be. So 2 times 8.9 times 7.2, and then cosine of 67. And I have 50.0761. We'll go with 4 decimals here for now. I know the answer at the end is going to have fewer, but I'm just going to keep them along the way. And this is equal to a squared, right? So we're going to add these pieces together, subtract off the ending one, so 79.21 plus 51.84, and then minus our 50.07610. And hang on, did I get that right? Yeah, I did. Okay. And so then the a squared right now I have is 80.9739-ish. Right? I rounded the very end off of there, but that's what I've got so far. Is that all right with everyone? Okay, that doesn't answer the question quite yet. I'm asked to solve the triangle, and right now I'm looking for side A, but I only have a squared, so what do I need to do? Yeah, I'll square root. So we'll square root both sides. And if I'm rounding to the nearest tenth, which is what this says, rounding to the nearest tenth, then the a value that I'm seeing on my calculator right now, the screen says, I'm going to write it out just so we've got it, 89985, and some more, right? So I'm rounding this to the nearest tenth. What is my a value? It's actually 9, or you could even put 9.0 if it's going to be particular about it inside of my math lab. I don't think it will. I think it'll take just 9 if that's the case. I took the square root. Okay, so that's a very good question. Isn't it plus or minus? So we're looking for lengths of sides, so we're going to use just the positive part. Thank you for mentioning that. I did take a square root. We're looking for positive lengths for everything that we're working with. Okay, so in other words, another way to think about this is a triangle, not in terms of like an ordered pair in space where we have negatives and positives. Okay, so this is meters. So this is 9 meters or 9.0 meters for side A. Now I'm not done. Right? I'm not done because I'm supposed to find all the sides and angles. And all I've done so far is find one side. Correct? This is the point that I mentioned early on. We could use the law of cosines again. There's nothing wrong with that. And we could find angle B or angle C using the law of cosines. Everybody good? Make sense of that, okay? Cool. But we don't have to. We could also use the law of sines, and the law of sines is easier to work with. Okay, it's trickier because of that ambiguous stuff. That's fine, but it's easier to solve from. So we're going to default to doing the law of sines. Now here's a caveat that you need to write this down. So I'm going to make the note of this, and I'm going to actually write it down. I would like for you to write it down as well. If you're going to switch to law of sines, which I am, you need to always find the smaller angle side pair, that's a slash, angle side pair next. Okay, so the ambiguous case happens when we have the possibility of an obtuse angle that's not too obtuse to make it too big, right? Do you remember that? I didn't exactly describe it that way, but that's when it happened. When the obtuse angle was too big, I ended up with too many degrees and I was more than 180. But when the obtuse angle was sort of small enough, maybe it was like 89 degrees. Or 107 degrees, right? When those cases were happening, that's when the ambiguous case was showing up. It was when I had something that was not too big and it was still possible to make it work. So if I just find the smallest angle, then this doesn't have the possibility of ever happening. So which of the sides is going to have the smaller angle, B or C? C. How do you know? You got it. Smaller side, smaller angle. So we're going to find angle C next. Okay, so we're doing a little prevention. We're preventing ourselves from making a mistake. And we might not make a mistake if we did it the other way, but we might. So the easiest thing to do is to simply prevent the possibility, and we can do that by finding the next one as the smaller angle. So we're going to find side C next. I think I need to shift this over a little bit, and we'll do this. All right, so we're going to do the law of sines. Okay, so we're going to take the pair of information that I know. I know angle A. So angle A, did I write it with the sign on the bottom? I think that I did. Different books do it differently. So it's this one like this, right? Okay. So we have our sine of 67 on the bottom. That's angle A. And I need to put on top of it side A. Side A is what I just found. It's 9. And the one I'm going to find is I'm going to find angle C. And I'm going to put side C on top. And side C was 7.2. Very good. Okay, now you've had practice doing law of sines. We're going to cross multiply. So this is 7.2 sine 67 degrees and 9 sine C. You could get a decimal approximation for the left if you would like. I'll just wait till the end. What would I need to do to solve this for sine of C? I'll divide by 9. And this will give me on the left, or on the right-hand side, sine C, which is what I'm looking for. And now I'm going to get my decimal. So I'm just going to get it at this point. So I have 7.2 sine of 67 divided by 9. And I'm going to write a decimal out. I'm going to write 6 decimal points, 7364004. And I'm going to do the inverse sine. So the inverse sine then will give me the angle C. All right. And it says my angles are going to be measured to the nearest angle. What does that mean? Or nearest degree, excuse me. What does that mean? Nearest whole number. You got it. So I need whole numbers for this one. And if I do whole numbers and I round, I think this is 47 degrees. Did we get 47? Okay, wonderful. Now, you could do law of sines again, or law of cosines to find the third angle, but that's really overkill. What is all we need to do in order to find the third angle? Yeah, we need to subtract them from 180 or add the two together and then subtract them from 180, right? So we have our 180 degrees as our total. We have a 67 degree angle and we have a 47 degree angle. So if I do 180 minus 67 minus 47, or you can add them first and then do so, we get our third degree, which is 66 degrees. Now, this is a good example of one where it wouldn't have mattered. If we had found the angle for, what angle was this one, B? If we had found angle B instead of finding angle C using the law of sines, it would have been just fine. How do I know? Well, because 66 degrees is a small angle, right? It wouldn't have had any problems at all. But it's better to be safe than sorry. It's not any harder to do it that way. So we want to just be careful on the front end. Okay, next one then. So this is an example, again, where we now have 3 sides given. We could not use, oh, you know what? I didn't mention it either. We can't use the law of sines with either of these. I mentioned it already for the other one, but do you know why we can't use the law of sines here?
Because you need to have at least one side for every side. You have to have at least one angle side pair.
You need an angle side pair. Yeah. See, do you see how every single one of these, A, B, and C, is listed? I have an angle for angle A. I've got the sides for B and C. In order to use law of sines, you need a pair. You need a side A and an angle A, or a side B and an angle B. And we don't have that here. Okay, so that's why this is necessary, is we don't just have like another way to do it and we're doing it differently. We can't do this with the law of sines from the first step. And the same is true here. I don't have an angle side pair. Instead, I have 3 different sides, which will make it a little bit different, but I don't have an angle side pair. Okay, so once again, we want to think carefully about how to find the right thing first to make sure that we don't encounter a problem with our angles later if we might have been in an ambiguous case. So this is a different one, okay? So this is a note to yourself as well. When given 3 sides, find the largest angle side first. I'm just going to call it like that. That's fine. I'm going to find the largest angle first. Well, why? Why am I going to find the largest angle first when before I found the smallest angle first? Well, over here, I found the smallest angle first because I was dealing with sine. Right? The law of sines ambiguous case happens because it's sine. On this one, I'm starting with the law of cosines, and the cosines never have this problem. When I find an inverse cosine of things, if you remember, inverse cosine is in quadrants 1 and 2. Quadrant 1 and 2 includes obtuse angles, right? The reason things got messed up with law of sines is because I'm in quadrants 1 and 4. Quadrant 4 does not include an obtuse angle. It gives me a negative angle, which would correspond to something over here in quadrant 2. So I don't have any concerns when I'm using cosines. So we need to find which one's going to be the largest. So which angle is going to be the largest angle? C. And it's because it's the largest side, right? So this angle that we're going to find is going to be angle C, which means my C value is going to go on the left-hand side. So let me write it out just so that you have it written. So this will be C squared equals A squared plus B squared. That's Pythagorean theorem. I know the letters are a little bit funky between the different 3 versions of it, but this is actually the Pythagorean theorem. You know, A squared plus B squared equals C squared. And then you have minus 2, and it's times the 2 sides that are on the same side, A and B, and then the cosine of C. All right, so C is 62.7, so 62.7 squared equals A, which is 42.9 squared, plus B, which is 37.6 squared, minus 2 times, and then I've got the same A and B, 42.9, 37.6, and then cosine of C. Now, this is messy. It's not hard, but it is messy. And you're all saying, thank you so much, you got to use a calculator, right? Because the messy and the calculator can deal with messy just like it can deal with clean. And so we're going to take the calculator and find each one of these values. So I have 62.7 squared, 31.29. Told you it was messy. 42.9 squared is 1840.41 plus 37.6 squared is 1413.76 minus, and I'm going to choose to multiply these pieces together and write that in front of cosine. So I have 2 times 42.9 times 37.6. That's what I have. Is that big enough to read? Am I writing too small? I'm looking at y'all in the back row because you guys are the furthest away. Olivia Grace, we're good? Eli, we're good? Okay, Chandrika says yes too. Okay. Did everybody get those values? Did I get them written down right? Okay, let's talk about how we clean this up. So what are we going to do to clean this up? Okay, we are. We're going to add these 2 together. That is our next step, and then we'll subtract it to the other side. You cannot combine the 2 yellow pieces with the piece that's multiplied by cosine, right? Because they're not both multiplied by cosine. Just a reminder about an algebra feature there, right? So we're going to add our 1840.41 and 1413.76. I have 3254.17. And then I will subtract, as you guys said, 32 54.17 to the other side. All right, I have 677.12 equals, and now it's a negative 3226.08. Don't lose that negative. Right? There's a negative right here because of the subtraction. It's still negative on the 3200 here. What do you do next? I'll divide by my 3200 number, and it's negative, right? So I need to divide by a negative 3226.08. All right, so moving along over here, I got negative 0.209889, if I use 6 decimals, is going to be equal to cosine of C. Then what? Yeah, we'll take the inverse. So we're doing the inverse cosine of this negative 0.209889. And I did, in fact, get an obtuse angle. Did you? Rounded to a whole number, it's 102 degrees. 102 degrees. I still need to find another angle. In fact, I need to find 2 more angles. One of them requires some work. The other one's really straightforward with some subtraction like it was the last time. Let me shift this up and we'll find our next angle. So what would I have to do in order to find the next angle? Yeah, I can use the law of sines. Now, if you really want to use the law of cosines and do the same process again, more power to you. But this is hard, right? I mean, like, really, it's complicated. You're bound to miss a decimal. I'm bound to miss a decimal point if I do this too many times. Like, it's going to happen. There's going to be a quiz, and my grader is going to contact me and say, Dr. Hands, this doesn't make sense. And I'm going to be like, you're right. I missed a decimal point, right? It's going to happen. So I will use the law of sines when I can. And it doesn't matter now which one we find. We know we've only got one obtuse angle. It's the 102 I just found. So you can find angle A or angle B. It doesn't matter. So which one do you want to find? B. All right, we're going to find angle B. So if we're going to find angle B, we need the sine of that angle C that we just got, which is 102 on the left, over C, which was 62.7. And we have angle B on bottom, so we've got 37.6 for the side on top, and it's sine of B on bottom. All right. Undoubtedly, I need more space. I need to do that when I create my slides, is allow a little bit of extra space. Okay. All right, so here's my one that we're working on. It's definitely now too small to read, but you've already written that part down, so I think you're okay. Okay. Where did that cosine come from? Was I right in this place? Ah. Okay, it's close enough. All right. So we're going to take this now and we're going to solve. So what's our first step? Cross multiply, you bet. So it's not the only way to do this, but that's a pretty natural one that most people like to do, is to cross multiply here. So 37.6 sine of 102. And then what would we do? Divide the 62.7, and that's when I'll get my decimal. So this is the sine of B is equal to 37.6 sine 102 divided by 62.7. I've got written down 58657, and if I round the last one, it would be 7. Is that all right? And then we will do our inverse sine, right? And remember, this can't be the ambiguous case. I can't get another obtuse angle. I already have one, so I know that I'm not going to run into any problems. Round to the nearest whole number. This is 36 degrees. Did you get 36? Okay, how do I find angle A then? Yeah, either add the two together and then subtract from 180 or subtract them as a get-go from 180. So I've got this. So I have 180 minus 36 and minus 102. And it's a 42-degree angle. And those are my three angles for this one. Okay. Heron's formula. Is that what's next? Yeah. I think I got my slides out of order. Here's the word problem. We'll go back to Heron's formula in a second. Clint is building a wooden swing set for his children. Oh, what a good dad. That's very nice. Okay. Each supporting end of the swing set is to be an A-frame construction. So it's going to look like an A with two 10-foot long 4x4s. So there's going to be a structure, whoops. It's going to look like this and this. This is called an A-frame, okay? This is what your sides are going to look like, and it tells you that each of them are 10 feet. It says 4x4s, those are just the thickness of the wood, so the way that the wood is constructed. They're joined at a 45-degree angle, so it's telling you that this one at the top is 45 degrees. Okay, is everybody good so far? They're constructed so they're joined together at a 45-degree angle. To prevent the swing set from tipping over, Clint wants to secure the base of each A-frame with concrete footings. How far apart should the footings be? So he wants to put something down in the ground to make this solid, right? So he wants to secure it in. If you've ever worked with setting up a swing set and you've not done this, the swing set has the potential for tipping over if you're not careful, especially if kids swing too high. It's happened, okay? So they're putting something really deep into the ground to hold this swing set steady. Okay, so the question is asking you how far apart these are. This is the question. Okay, so we're going to find this third side. All right, we can label them if you'd like. So if we want to label them, this would be side A, and this would be side B, and this would be side C. And the angle we would be given across from there then would be angle C. So we are given one angle, angle C, and we are given sides A and B that are not matching that angle, right, in terms of the letter structure that we've set up. So we've got the law of cosines. The one we're looking for is side C, so it's going to be on the left. C squared is equal to A squared plus B squared minus 2AB cosine of C. Everybody good? Okay, C is what we're looking for. That's actually, this is a nicer version than, I get that word problems require you to set things up, but they're nicer than the solving triangle ones because you're only finding one piece. Y'all with me on that? That's generally an easier thing to do than finding all three pieces of a triangle. So the sides A and B are actually both 10s. So we have 10 squared and 10 squared minus 2 times 10 times 10, very friendly numbers as well. Cosine of the angle we were given, which is a 45-degree angle. Now, this is an angle we know. That's fine. And if you want to use what you know about this angle, which we can, that's fine too. It's square root 2 over 2. But in the end, I need a decimal answer because if you tell Clint how far he needs to set his things apart in square roots, he's going to cross his eyes at you. Do you understand what I'm saying? We don't talk like that when we're actually measuring things. We find the decimal length of things. So while in most cases we want to keep things as exact as possible, in a word problem, we don't. We want a decimal value because that's what makes sense from a contextual standpoint. So feel free to just use the calculator and find cosine 45 degrees as well as you're doing this, and don't do it as a square root 2 over 2. Each of these are really nice values. This is 100 plus 100 minus 200. And then if you want, you can do the square root 2 over 2 here, which would be fine. This actually will simplify to give you a 100 here. That's great. Use your calculator too. That's great. So if we add this up, I have 100 plus 100 minus 100 square root of 2, or you can type it all straight into your calculator. This gives us 58.5786, I don't know, some more stuff. And then I need to do what? I need to take square root. So the C, I'm almost done, I promise, will give us 7 point, did it say how many decimals? It doesn't, so let's go with 1 decimal. They usually do side links to 1 decimal, so this would be 7.7 feet, because they're 10-foot pools, right? Yeah, feet. Okay, so 7.7 feet apart. All right, I'm going to push pause on this.